Let me work on getting that wired up. In this video, we pick up where we left off in the last video, working on the register control circuitry, extending that by adding the demultiplexer and testing and debugging the new wire-ups. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Okay, that takes care of extending the control lines. So the next thing, I have this clear signal, and I'm going to move this over just so that it's right next to the... Actually, I'm going to pull it over this way so it's sitting next to the register itself. So the last thing I said I wanted to be able to do was to demultiplex the input signals at the register. And to do this, I have a couple of choices. There is a 74 LS138, which is a 3 to 8 line decoder demultiplexer, which I maintain in stock, and there's a 74 LS139, which is a dual 2 to 4 decoder demultiplexer. I only have 3 inputs that I need to handle, and those are, let me grab my little cheat sheet here as to how things are wired up. That is load, increment, and decrement. So I still have a 4th that I need to maintain for do nothing. So the dual 2 to 4 line demultiplexer would actually suit just fine. But I did some research because I was concerned about the availability of the 74 LS139 2 to 4. And while I can get what I'm looking for, it is 3 times the cost as a 74 LS138. And so what I'm going to do is I'm just going to go ahead and use the 138 and save that money. And so I'm going to line this up to go in right here. And again, I'm going to put in power and ground in all the normal places. So power up here. And ground down here. And then pulling up the pin diagram on the screen, looking at the 138, I have an A, B, and a C, which are select. And A happens to be the least significant bit. So A would be the 0 or 1, B would be the 2's in binary, and C would be the 4's in binary. We want to tie C low, which is pin 3. So pin 3 gets tied low so that I am only using the first 2 pins. Now the outputs are going to be load, increment, and decrement, and these are going to come off of, these are going to be these first 3 lines here. Load is going to be pin 1, which is 14. Pin 0, or output 0, is going to be unused. Pin 2 is going to be pin 13, and pin 3 is going to be pin 12. So now I just need to set up the inputs for do nothing, and then I need to set up the enables. So I always want to be able to be outputting, because if I'm doing nothing, the output is going to be on pin 0. So if G1 is high and both G2s are low, we're outputting. So G2A, which is pin 4, tied low. I got the wrong color. pin or cut or wire here. All right, try that again. Pin 4 is tied low. Pin 5 is tied low. Let's try pin 5 this time. And pin, let's see if I can find a slightly longer one here. Pin 6 is tied high. Then I should be outputting. So if I have 1, 2, and 3, and those line up appropriately here. So 0 means that I have output on this pin, which would be pin 15. And so that one is low. The other 3 are driven high. If I change the A select, which is the least significant bit, to 1, pin 1 is low, which turns that LED on. Pin 2, which is, or I'm sorry, binary 2, which is pin B high, pin A low. The second output is low. And then if I set all 3 of them, or set it to 3, then the third LED is on. And that's working the way I want it to. So what that does then is that gives me 2, 4, 6, 7, 8, 9, and a clear is then the 10th pin. So I can fit all of the control signals I need into a 10 wide ribbon cable, which is nice because my ribbon cable is 10 pins wide. Go figure. Okay, the last thing I need to do then is this output here. So these 16 lines up here need to be brought back down to the inputs down here so that it's connected, the output is connected back up to the input. And to do this, I think I'm going to use ribbon cable and come out and around the side to make the connections easier. And I'm just going to extend these 16 lines out here, making sure they remain in order, or they actually get converted to order, because remember I actually had to flip the orange and the yellow pins here when I was wiring up the increment and decrement. And I'll put a card up in the upper right hand corner of the screen there. I have 21, maybe 20 pins between this and this, so that gives me plenty of room to fit that in. So I'm going to do that extension and get this wired up here with ribbon cable. And then the last thing to do is going to be to find where I can basically put this clear line and get it wired up. Okay, here we go. Okay, before I get into the ribbon cable to connect this section to this section, I want to take care of these wires here as well. And then the decoupling capacitor. Finally, I can take this clear line and wire it down to this signal down here. So that then gives me my signals. I have 3 of them that sit here, which is where I'll tie in. I have 2 more that sit here. And then I have 5 that come up here. So on one end of my cable, I will have 10 pins, and the other end I will break that into 5 and 2. I'm sorry, 5 and 2 and 3. That's correct. 5, 2, and 3. So that I can drop them into 3 different places on the board. Last thing is to create that ribbon cable, and in order to do that, I'm going to have to clean up a little bit to make some room. Okay, I've got my cables made now. So it's not plugged in at the moment. I made 3 cables. This one in particular has 3 ends on it, and as I said before, these 3 ends will go into this group here. 2 will go over here. I need to make sure that they're lined up properly. And then 3 will go over here. And then the end of this then now becomes my control signals that I will pipe in from some other place. But these now can go away, and when I test, I will have to hook up new connections there. The other piece that I wanted to do was to hook up, again, the output of the main bus down here so that the main bus now let's do this. So that the main bus is actually looped back around to be the input. Okay, let's come down here. Okay. And then I've got those routed off the board so that you can still see the LEDs. So let me bring the clock back in and hook it back up. And then my output here, which I can now tie into the main bus at this point. My input, which can also be tied into the main bus. And then the only other thing I need to do now is set up my controls. So for that, I will grab just another random breadboard here. And as I'm wiring this up, I'm looking at my cheat sheet here. And the one that is not written down there is clear. And clear is an active high signal. Yeah, master reset is active high. Load is active low, which is the next one. And then, well, actually, load, increment, and latch are all hooked together. Okay, the bottom 6 lines are all active low, and they are used to control the output to the different buses. Then the next 2 are the now I forgot. How embarrassing is that? Well, let's just go in and test it. We'll figure this out on the fly. Because apparently I don't make good notes. Let me get power and ground chained over. Okay, so I've got 2 that are active. Okay, so let's do some troubleshooting here, because obviously things aren't working the way I intended. First thing let's clock. and make sure. This first line here is master reset. So if I bring that high and bring it back low and clock, it should reset everything. Let's bring that back high and clock. Bring it back low. And it is not changing. So we'll bring in the logic probe and see what we can determine from that. Okay. First of all, that's low and that's high, so I am getting power and ground. This is a low signal, which brings this over here to be a low signal. And if I switch this to high, I do get high and then back to low. So this signal is correct. So now it worked. That's low, that's low. Okay, so that's coming off of here. So that's high, which is coming in here, high, now low. I have a bad wiring job. So 1, 2, 3, 4. So that's low when it shouldn't be. Okay, so clear. These two are the ones that are. Let me just switch this around to make this a little easier to understand. So the two green lines here are the ones that I need to use to indicate one of load, increment, or decrement. And then this is a latch signal, which is high. So if I have clear, and latch, and then if I set this to be, let's do nothing. So 1, no, that's 2, this is 1. That should be and latch. So load and latch. All right, 0, 0, 1, no, 1, 1, 0, 1, 1, 0, 0, 1. 0, 1s. That's not lining up right at all. What is going on there? Let's turn everything off. And we'll start with the most significant bit. Okay, this will work better this way. And that's because somehow I managed to put that marginally upside down. Okay. Which makes that difficult to operate. So here we go. Everything is off. And now if I do my load, everything's on. So Okay, so there are still some shorts somewhere because these are back on. So the shorts would be in here. Good God, Adam. Adam, you're certainly not doing yourself any favors today. Okay, all off. And that's the bottom 8 bits. So that works well. Clear works. And then, so this one should be output byte swap. Now, I do not have pull down resistors here. And because I don't have pull down resistors here, the outputs are floating. No, that doesn't make sense. Something is outputting when it should not be. Is it this that's outputting? Yeah, because I'm not pushing this through a line driver. And that's why, yes. So that's very bad to do. So let's get a 2, 3 is a decrement and load. It at least gets me something in there so that if I output the main byte-swapped order, that is not byte-swapped order. That is byte-swapped order. Do I have those correct? So that's natural order. And that's byte-swapped. Okay, so I may just change my definition, although I probably did something silly in the wire up. So let's see here. Let's stick my head away. This is high, which is correct. This is low. And I want... So this is outputting. It's supposed to be byte swapped. These need to go over here. So once again, reorganize my wire bins here. Okay, so that should be, this one should be byte swapped, and it is. And this is the main. That's correct, finally. Okay. So that is all working as I intended it to. This ribbon cable here will get moved over to the control module. This is my stand-in for the moment. Input probably needs to have a line driver on it so that whatever's happening, whatever's being asserted to it, happens correctly and I don't end up pushing two signals out there. But I believe this is now all working the way I need it to. And I believe, if my thinking is correct, this wraps up my register. The next step will be to move this circuitry into KiCad in preparation for this to be placed as a PCB order so we can start working on the final computer. I do still have to troubleshoot the single step balances on the clock. I have some video on this. I know what the issue is. but in the interest of keeping the videos at a reasonable length, I have not published that video yet. I will work on getting that published quickly. And I've got a couple of parked items. I'll probably do some time fill with the variable resistor upgrade. I do want to get into the definition of the assembly language relatively quickly. It will give us context for a lot of the control circuitry that we build out. And I believe it's important to do that definition earlier rather than later, so that we can actually work towards a goal as opposed to just pull it all together. I also identified a problem with my bus input test harness. It needs to have a line driver added to that. I'll work on getting that done and transfer that onto a larger breadboard. Thank you. We'll see you soon.